Hello, and welcome to Echoes of the Forgotten Earth, a place where curiosity settles in like a warm blanket and science meanders gently toward wonder. Tonight, our quiet path leads us into one of the strangest and most unsettling mysteries we've ever encountered. Not just as scientists or thinkers, but as human beings sitting together beneath a common sky. This mystery is called the Great Filter. If that name is unfamiliar, that's all right. It sounds more like a gadget you'd buy for a coffee maker than a concept about the fate and survival of civilizations. But once you truly grasp what it implies, you might never look at the night sky in quite the same way again. The Great Filter is an idea that tries to answer a haunting question. Why do we gaze out at a universe filled with stars and planets and yet receive no reply? No messages, no neighbors, no busy traffic of distant minds, just a vast, echoing quiet. And in that quiet, there may be a message about our own chances of surviving far into the future, one that is not necessarily comforting. Before we walk too far down that path, let me pause to ask you something simple. Where are you right now as you listen? Are you wrapped in blankets, the room dim and still? This playing softly as you drift towards sleep? Are you stretched on a couch with headphones on while the city outside hums and flickers? Are you standing under an actual sky, hearing crickets, distant trains, or a breeze moving through trees while you listen? Each of us arrives at this moment from a different place, wrapped in a different life. Yet above all, those different lives is the same universe, hanging overhead in quiet enormity. There's something comforting about that. So, wherever you find yourself, thank you for sharing this time. And if you feel this quiet exploration eases your mind or stirs your curiosity, consider leaving a like or subscribing. It helps this calm, reflective corner reach others who might be in need of a gentle pause. And perhaps tonight, a gentle meeting with one of the universe's darkest questions. So then, the Great Filter. What is it? And why does it matter to us? The story begins with a deceptively simple question. It was first voiced by the physicist Enrico Fermi over lunch in 1950. He asked, "Where is everybody?" He wasn't talking about missing invitations or an empty birthday party. He was talking about other civilizations, intelligent beings elsewhere in the cosmos. Given how many stars there are, and how many planets most likely circle those stars, it seems overwhelmingly likely that intelligent life should have arisen many times. Fermi pointed out that even if life hardly ever appears, the sheer bewildering size of the galaxy suggests that at least a few civilizations should have emerged long before us and spread outward. If you think about the odds billions of stars, billions of worlds, countless configurations where conditions might be just right for life, it seems almost inevitable that someone out there should, by now, have built the means to travel, to explore, or at the very least to send a clear signal. Yet we see none of that. No great networks, no obvious engineered wonders, no clear evidence at all. Only silence. The Great Filter is one possible answer to this puzzle. Perhaps the reason we don't see anyone else is that almost no one manages to get past certain, incredibly difficult steps. These steps are the filters, barriers in the path from simple matter to advanced civilizations. They are so challenging that almost everything that tries to pass through fails. Civilizations might rise briefly, glow for a moment on their planet, and then fall before they can spread so far or grow so powerful that we would notice them. The filter could lie in our past, buried in some unimaginably unlikely step perhaps in the initial spark of life itself, or in the transition from single-celled organisms to complex, multicellular beings. If one of those steps was so rare that it almost never happens, then we may already have passed through the Great Filter. In that case, we are unimaginably lucky just to exist at all. But the filter might instead lie in our future, waiting for us like a hidden reef under calm water. It could be some catastrophic threshold that nearly all civilizations hit once they become technologically capable. Something that almost no one survives. nuclear annihilation, environmental collapse, runaway technologies, or dangers we haven't yet even imagined. Dark tides that sweep societies away before they can reach the stars. And that's where the unease begins to creep in. If the great filter is behind us, then perhaps we're relatively safe. But if it stands ahead, we may be moving toward it without realizing. The universe's eerie silence becomes less a curiosity and more a warning. Step outside on a clear night and look up. The number of stars can take your breath away. In our galaxy alone, the Milky Way, there may be 200 to 400 billion stars, perhaps more. Many of them are older than the sun. Many possess planetary systems. Modern telescopes have shown us that planets are not a rare luxury of the cosmos. They're everywhere. Almost every star we look at seems to have some. There are gas giants larger than Jupiter, small rocky worlds somewhat like Earth, planets that might shelter oceans, moons with hidden seas buried under ice. The universe appears crowded with real estate world after world after world. By any reasonable guess, the galaxy should be bursting with potential. And yet, when we point our instruments outward, listening for structured signals, for signs that someone out there is transmitting, the static stretches on. The quiet remains. That is the puzzle. This silence is not what our calculations would lead us to expect. It's as though you walked into an enormous stadium and saw every seat filled. You'd expect sound voices, footsteps, coughs, laughter, whispers, some hint of life. Instead, you hear nothing. No movement, no murmur, just the faint hum of the lights above and the sound of your own breathing. Everything suggests there should be noise, and yet there isn't. That's how the universe sometimes feels. The numbers suggest that intelligent life should have had plenty of time to arise, flourish, and spread. The probability seems to lean toward abundance. But when we actually look and listen, the evidence leans toward emptiness. We humans have been leaking radio waves into space for only about 100 years. On a cosmic timescale, that's less than the blink of an eye. If other civilizations gained even a small head start, just a few thousand or a few million years, they'd likely be unimaginably ahead of us in technology. They could have spread across their star systems, maybe even across the galaxy. This central tension is often called the Fermi Paradox, named after Enrico Fermi. The heart of it is contained in that short question: where is everybody? With so many chances, so much time, and such vast distances to work with, why does the sky not ring with evidence? You would expect a busy cosmos signals flashing, strange structures built around stars, clear signs that others have passed through. Yet we get only silence. We wait for unmistakable alien broadcasts. We search for stars dimmed in peculiar ways, as if something were harvesting their light. We watch for patterns, for anomalies. We don't see any we can be sure of. Just us on a small, pale world, hoping that someday we might hear a simple word from somewhere. Hello. Some people respond to this by saying, maybe we just haven't checked enough. And they're right in an important sense. Our search has been shallow compared to the scale of the cosmos. We've scanned only a tiny fraction of the stars out there. Our instruments, while impressive to us, are still young and limited. For all we know, the signals could be real, but faint. Like very distant whispers we haven't aimed our microphones in the right direction to catch. It's also possible that the signals come in sporadic bursts, maybe centuries apart, and we've merely been listening during a quiet interval. The search for extraterrestrial intelligence, often abbreviated as SETI, is ongoing. But what we've done so far is a little like standing on the shore of a vast ocean, dipping in a single cup of water, and declaring, there are no whales here. The sample is that small compared to the whole. Yet even with those limitations, the quiet feels odd. If advanced civilizations were common, we might expect at least some of them to leave footprints big enough to notice, even from far away. Imagine a species millions of years ahead of us building vast structures around its star to capture energy so-called Dyson spheres or swarms. These would radiate waste heat that might show up on our telescopes as something strange and unnatural. Surveys of many thousands of stars have looked for such anomalies. We've seen a few odd cases, such as a star known as Tabby's star, whose brightness dipped in puzzling ways and briefly sparked ideas about alien megastructures. But so far, the more mundane explanations, dust, comets, or unfamiliar stellar behavior, seem more likely. The more we look, the more the puzzle deepens. If intelligent life is supposed to be probable, why does the sky feel so lifeless? Scientists have offered a wide range of answers, and some of them are surprisingly gentle. Perhaps other civilizations are out there, but so distant that their signals simply haven't reached us or are too faint to detect. Or maybe they communicate using methods we haven't even considered. Instead of radio waves, they might use neutrinos, gravitational ripples, quantum entanglement, or techniques so advanced that they blend into what we currently dismiss as background noise. If that's the case, then the quiet isn't really a sign of absence. It's just a mismatch, like trying to tune an old radio to pick up a fiber optic cable. Other suggestions are harder to face. Maybe many civilizations end themselves. Perhaps they discover powerful technologies and fail to handle them wisely. They might be undone by wars, ecological collapse, or tools that spiral out of their control. In that scenario, the silence we hear isn't because nothing ever grows intelligent, but because almost nothing intelligent stays alive long enough to be noticed. The quiet becomes less about distance, more about destiny. The strangeness of the silence isn't just that we don't currently hear signals, it's that there has been so much time for someone, somewhere, to become clearly visible. Our galaxy is around 13 billion years old. The solar system is about 4.5 billion years old. That means there were billions of years before Earth even formed, more than enough time for other civilizations to appear, flourish, and spread. Imagine just one civilization with a billion-year head start. A billion years is almost beyond imagination. In that span, a species could colonize the galaxy many times over, reshape entire systems, build wonders we can hardly describe. If even one such civilization had endured, you would expect its traces to be scattered all around us. We should live in a galaxy clearly marked by intelligent activity. Yet the evidence we see is purely natural. This contradiction between what seems probable on paper and what we actually observe has led people to suspect some universal barrier. Something that prevents life from either starting often or from rising very far when it does. That's where the idea of the Great Filter steps in. But before diving into possible locations of that filter, it's worth pausing to appreciate how loud this silence really is. Because this kind of quiet isn't neutral. It carries information. Every time we build a new telescope, scan another patch of sky, or analyze more starlight, and still find nothing, that emptiness becomes another data point. A quiet one, yes, but a data point all the same. It suggests something deep about the nature of the cosmos, and possibly about the arc of our own future. Humans, however, are storytellers. When we face silence, we fill it. Some imagine a universe full of life that has chosen not to reveal itself. This is sometimes called the zoo hypothesis. In this story, Earth is like an exhibit. Advanced civilizations know about us but keep their distance, watching but refusing to interfere, the way we might observe animals in a reserve. From our perspective, everything looks silent. From theirs, the silence is deliberate. Others imagine civilizations that turn inward. At some point, they might build internal worlds, simulations, digital paradises, or immersive realities, so rich and compelling that exploring physical space becomes irrelevant. In that case, they still exist, but they no longer send loud, obvious signals into the cosmos. Their civilizations continue, but their gaze is elsewhere. And then there's the possibility that we truly are the first. That intelligence in the galaxy is only just beginning to appear, and for reasons we don't understand, Earth happened to get an early start. If that's true, then the silence around us isn't a threat. It's the hush before the first notes of a song. We might be sitting in a theater before the curtain rises, waiting for other voices that have not yet had time to emerge. If that is the case, then the future could be anything but quiet. One day, the galaxy might be full of exchanges, networks, signals, an intricate web of conversations. We just happen to be early, listening before the orchestra begins, and yet we can't quite shake the uneasiness, because the silence isn't easy to shrug off. Each explanation brings new questions. If everyone is quiet by choice, why all of them? If almost everyone is destroyed, why everyone? If we're the first, why us, when so many stars and planets got started long before our sun? The quiet feels heavier than mere emptiness. It feels like an absence that shouldn't be there. Like sitting in front of an orchestra, hearing the tuning, and then realizing the conductor never appeared and the performance never begins. The mystery of the silence is not just a question for astronomy textbooks. It is also a mirror. In its reflection, we see our own hopes, our own fears, and our uncertainties about what lies ahead. When we look outward and hear nothing, some part of us wonders whether we are glimpsing our own fate, that perhaps we too are destined to disappear into the same vast quiet that seems to blanket the galaxy. And yet another part of us dares to imagine that silence as a pause, an empty space, waiting for us to fill it. If you've ever had a question arrive in your mind at the wrong moment, you'll recognize how this entire cosmic puzzle first surfaced. It was the summer of 1950 in Los Alamos, New Mexico. A small group of physicists sat together at lunch, talking casually about everything from nuclear research to newspaper cartoons. The mood was light, the conversation scattered. Then, cutting through the chatter like the sound of a glass shattering on the floor, Enrico Fermi asked a question. Where is everybody? The everybody he meant was not the late colleagues or missing guests at the table. Fermi was talking about aliens, intelligent beings beyond Earth. Life capable of technology, communication, and curiosity. Given the incredible age of the galaxy, billions of years older than our planet, and the staggering number of stars and planets, it seemed almost inevitable that civilization should be scattered everywhere. They should have risen, expanded, and left some trace behind. Yet when we look out, we see no such traces. We listen, and we hear nothing. The scientists at that table laughed. They joked about flying saucers and newspaper headlines. The moment moved on, but the question stayed. Over the years it grew, took shape, and came to be known as the Fermi Paradox. A paradox because the math points one way, toward a galaxy heavy with life, while the evidence points in the opposite direction, toward profound loneliness. It is a paradox born from the clash between probability and reality. Imagine stepping into a dense forest with thousands of trees. You'd expect birds, chirps, rustling wings, calls from the canopy. If you spend hours in that forest and hear nothing, no flapping, no song, not even the faintest rustle, you'd begin to wonder. Perhaps the birds are there but silently hiding. Perhaps they sing in a pitch you cannot hear. Or perhaps, for reasons unknown, the forest is simply empty. That uncanny stillness is what Fermi's question was pointing to. To see why it carries so much weight, it helps to examine the numbers behind it. Our galaxy contains hundreds of billions of stars. We now estimate that at least half of those stars host planets. Many of those planets fall into what we call the habitable zone, the distance from a star where temperatures could allow liquid water to exist. Even if life begins on only a tiny fraction of those worlds, you would still be left with millions of potential homes for biology. And if evolution works even somewhat like it did here, you'd expect that on at least a few of those planets, life would grow more complex. Some of those organisms should eventually become intelligent. They should learn to make tools, form societies, build cities, and wonder about the sky much as we do. Now imagine one such civilization gains a head start of just a few million years. On the timescale of galaxies, a few million years is barely a sliver. Yet in that short head start, their technology could outrun our own to a staggering degree. They might traverse their solar system, dispatch probes to neighboring stars, or slowly expand across large swaths of the galaxy. 1,000,000 years is unimaginably long when measured by technological progress. We went from animal-drawn carts to interplanetary probes in only a few centuries. What would someone with 10,000 centuries accomplish? With that in mind, the silence begins to feel less like a simple mystery and more like a riddle with sharp edges. Because even if only one such civilization had expanded, its influence should be noticeable. It wouldn't have to wrap the galaxy in shining cities or swarms of ships. Just by harvesting large amounts of energy or reshaping parts of its environment, it would leave fingerprints on the sky. Yet when our telescopes search, what they return is mundane. Ordinary starlight, dust, gas, and phenomena that can be explained by natural processes. So again, we are left asking, where is everybody? Some thinkers suggest that the question might be flawed from the start. We assume that intelligence would behave like we imagine we would behave. Expand, explore, communicate loudly. But what if that assumption is wrong? Perhaps advanced civilizations are cautious. Perhaps they learn that drawing attention to themselves is dangerous and so they stay quiet. Or maybe they reach a point where the external universe ceases to matter much at all. They might turn inward, building intricate digital worlds or internal realities that are far more interesting than the cold vacuum of space. In that case, they would still exist. They just wouldn't be leaving obvious marks for us to find. The universe would appear empty to us, while being full of minds that have simply chosen not to broadcast. Others argue that the evidence may be right in front of us, but we lack the imagination or technology to recognize it. Our current search focuses largely on narrow bands of radio waves and certain types of physical structures, but perhaps advanced beings long ago moved beyond such crude methods. They might encode information in particles we hardly detect or use effects in physics that, to us, look like random noise. It would be a little like a fish trying to detect Wi-Fi. The signal could be strong and constant, but the fish, lacking both the concept and the tools, would never know it was there. There is, however, a darker way to hear Fermi's question 1 that leads directly into the idea of the Great Filter. In this line of thought, civilizations do appear, but something reliably and almost inevitably stops them before they can spread very far. They arise, expand for a time, and then falter through war, ecological catastrophe, uncontrolled technologies, or other disasters. They don't endure long enough to become visible on a galactic scale. The stars remain quiet, not because no one ever lit a fire, but because every fire burned out. It's worth noticing how deeply human this question is. On the surface, it's about star counts and probabilities, about telescopes and equations, but underneath, it's about ourselves. When we ask, where is everybody? We are also asking, what does their absence mean for us? If the galaxy is empty, does that mean life itself is vanishingly rare and we are a precious exception? Or does it mean that life appears often but collapses almost every time, and we are simply another civilization moving toward the same end? The Fermi Paradox does not answer these questions. It only sharpens them. It tells us that something is missing in our understanding, that our expectations and reality do not align. It leaves us with a silence that feels heavy with implication, a quiet that might be comforting, threatening, or both. Human beings, however, do not like leaving puzzles unsolved. We build frameworks to grapple with them. Formulas, theories, hypotheses. One of the best-known tools for thinking about this problem is the Drake equation. Rather than promising a precise answer, it breaks the big question: how many detectable civilizations are there? Into smaller parts. It considers the rate at which stars form, the fraction of those stars with planets, the fraction of those planets that might support life, the fraction of life-bearing worlds where intelligence arises, and so on. Each piece is uncertain, but together they give us a way to organize our ignorance. When scientists plug optimistic values into the Drake equation, they get answers in the thousands or millions of civilizations. When they plug in pessimistic guesses, the answer shrinks towards zero. That wide range reflects how little we know. Somewhere in that chain of steps must lie one or more bottlenecks filters that are far more severe than they might appear at first glance. When you think back to Fermi's simple lunchtime question, "Where is everybody?" it becomes clear how profound it really is. In only 4 words, he forced us to face both the size of the universe and the fragility of our presence within it. It's the kind of question that lingers long after the conversation ends. It may drift through your thoughts while you wait for water to boil, or browse headlines, or drift off to sleep. Once you hear it, you cannot unhear it. The night sky feels different. The quiet feels louder. Stand under that sky and try to count the stars. Even in a dark place far from city lights, you'll see more than your eyes can easily track. The faint band of the Milky Way alone holds more stars than you could count in a lifetime. Astronomers estimate that our galaxy contains roughly 200 to 400 billion stars. It's a number so large that language begins to fail. If you tried to count one star per second without stopping, you would still be counting thousands of years from now and would not be finished. And the Milky Way is only one galaxy among trillions. Beyond its spiral arms lie countless others, great clusters and faint smudges, each with its own families of stars, its own history, its own worlds. Astronomers sometimes describe this as a kind of cosmic lottery. Each star is a ticket. Each planet orbiting those stars is like another layer of tickets. Taken together, the number of chances for life to arise should be immense. For most of human history, we had no idea how many other planets there might be. Some thinkers even imagine that planetary systems like ours were rare or unique. But over the past few decades, with the help of space telescopes such as Kepler and TESS, we've gone from guessing to knowing. We've detected thousands of exoplanets, worlds orbiting distant suns. The more we look, the clearer it becomes. Planets are common. Nearly every star seems to host them. Some systems have many, dancing in tight configurations, each following its own graceful path. Among these worlds are planets that lie in what we call the habitable zone. This is the range where it's not too hot and not too cold for liquid water to exist on the surface, assuming the right kind of atmosphere. Water, at least as far as we currently understand, is one of the key ingredients for life. For that reason, the habitable zone has earned a second name, the Goldilocks zone, where conditions might be just right. Being in the habitable zone does not guarantee life. It is only a starting point. But when you combine the number of stars, the number of planets, and the fraction that fall into that comfortable region, the potential homes for life become overwhelming. And that's where an almost instinctive optimism often begins. If the galaxy is full of worlds where liquid water might flow and chemistry might flourish, then surely life must have taken hold many times. If life arose once, why not many times? On Earth, life seems to have appeared relatively quickly, once conditions were hospitable. Geological evidence suggests that the earliest life forms emerged almost 4 billion years ago, not long after the planet cooled enough to support oceans. That rapid appearance makes some people think that life isn't just possible. It might be something that naturally emerges whenever the right ingredients and conditions come together. But raw numbers and intuitive feelings can be misleading. Think about buying a lottery ticket. The odds of winning might be 1 in 100 million. If you buy just one ticket, your chances are minuscule. If 100 million people each buy one ticket, someone is almost guaranteed to win. Now imagine a lottery where you don't even know the true odds. The universe might be hosting that kind of game. With so many stars and planets, every instinct says that someone should have won by now, should have become visible to us. Yet here we are, staring at a result that feels like a losing streak. We have all these tickets, all these planets, and all this time. And still, we see and hear nothing. We wait for the announcement of a winner, but the loudspeakers remain silent. This conflict between expectation and outcome is at the heart of why the Great Filter feels so unsettling. The stars suggest abundance. The planets suggest possibility. The history of life on Earth suggests that once life starts, it can become complex and vibrant. And yet, the empty sky suggests that somewhere in that chain, something is far rarer or more dangerous than we assume. Either the step from non-living chemistry to living organisms is incredibly hard, or the step from simple life to complex, intelligent life is. Or perhaps intelligence almost always destroys itself before it can travel far. The Drake equation helps us frame these possibilities, not by solving them outright, but by reminding us that the silence we hear is not the result of a single probability, but of many linked together. Each stage in the development of life and civilization multiplies with the next. If even one of those stages is extraordinarily unlikely or routinely fatal, then the final number of civilizations capable of signaling across the stars could be tiny. When scientists fill in the Drake equation with hopeful values, the galaxy lights up with estimates of many civilizations. When they use more pessimistic numbers, the result can shrink to one or less. That huge range tells us that we don't yet know which step or steps are actually doing the filtering. It's important to recognize how ordinary Earth is in many ways. The atoms that make our bodies, carbon, hydrogen, oxygen, nitrogen, are among the most common in the universe. The water we drink, the rocks we stand on, the air we breathe, all follow the same physics and chemistry that operate everywhere else. Gravity, radiation, magnetic fields, the life-giving warmth of a star. These are not rare or unique features, and that is part of what makes the silence so confounding. When you tally up the ingredients and the opportunities, it feels as though we should not be alone. And yet, every time we look carefully, we come back empty-handed. Some researchers describe our situation this way: either we are extraordinarily rare, or we are in extraordinary danger. If life and intelligence are incredibly uncommon, then perhaps we really are alone, or nearly alone in the galaxy. The result of a sequence of events so improbable that it may never repeat. That scenario is lonely but hopeful, because it means that the great filter likely lies in our distant past. We have already succeeded where almost everything else has failed. If, instead, life is common, but we still see no thriving civilizations, then something else must be at work. A shared obstacle that stops most societies from lasting long enough to be noticed. In that case, the filter would lie ahead, and our odds of survival might not be good. The universe's silence would be less a blank and more a graveyard. We don't yet know which of these pictures, if any, is true. That uncertainty can feel heavy, especially when we let ourselves think about it deeply. Yet there is also something grounding in it. No matter how many stars exist, no matter how many chances may lie out there, the only world we know for certain is this one. The only civilization we have any direct influence over is ours. When we zoom all the way out, the statistics can leave us dizzy. When we zoom back in, what matters most is how we treat the fragile chance we've been given. To be wiser, more careful, more deliberate. In that sense, the Great Filter is not only a theory about others, it is a mirror held up to us. It asks how resilient we really are. It asks whether we are taking our own risks seriously. It asks how fragile our place is in the unfolding story of the universe. Because wherever the filter lies behind us, ahead of us, or scattered all along the way, what we do next still matters. When we talk about the Great Filter, one of the central questions is whether it lies mostly in our past. If it does, then the quiet of the galaxy might not be an omen of doom, but a sign of how astonishing it is that we exist at all. To explore that possibility, we have to trace the story of life on Earth from its earliest beginnings and notice how many fragile, uncertain steps had to succeed in exactly the right way. From a distance, the path from molecules to minds can look smooth, almost inevitable. But up close, it looks more like a cliff carved into narrow ledges, any one of which could have collapsed beneath us. At the very beginning, there was a young Earth, a hot, volatile world, battered by impacts, its surface still shifting and settling. Volcanoes spewed gases into a growing atmosphere. Asteroids and comets rained down, sometimes delivering water and organic molecules, sometimes causing devastation. Somewhere in that chaos, the right combinations of conditions emerged. Simple molecules methane, ammonia, water, carbon dioxide, interacted in seas, ponds, and perhaps deep-sea vents. Energy from lightning, ultraviolet light, and geothermal heat drove reactions. Out of that churning chemistry, more complex molecules formed. Amino acids, lipids, nucleotides. These are the ingredients of proteins, cell membranes, and genetic material. But ingredients alone are not life. The leap from a soup of molecules to a system capable of copying itself and evolving is still a mystery. We have ideas, RNA-based worlds, lipid bubbles that trapped useful molecules, networks of reactions gradually gaining stability, but not a complete picture. We don't know how likely or unlikely this step really is. If that first transition is vanishingly improbable, then it may already be the great filter. Life itself would be the barrier that almost no planet crosses. If that's true, then Earth is something like a cosmic outlier, a startling exception in a universe mostly filled with sterile rocks and gas. In that scenario, the silence of the stars is no surprise at all. Of course, we don't hear anyone else. Almost no one else ever existed. In that case, the filter would indeed be behind us, and our future would not be doomed by some universal law. Our challenges would be real, but not predetermined. We would still need to avoid destroying ourselves, but we would not be facing a built-in, near-certain collapse encoded in the nature of the cosmos. But suppose that first spark of life is not so rare. Suppose that, given the right conditions, chemistry tends to stumble into self-replication and evolution fairly often. Even then, our path does not become simple. For a huge fraction of Earth's history, life was unimaginably small. Microbes ruled the planet for billions of years. They filled the oceans, crept through sediments, colonized rocks, and thrived in boiling vents and frozen ice. They changed the atmosphere, producing oxygen that reshaped the planet. Yet for all that time, nothing more complex than single cells seemed to appear. That long plateau hints at another possible filter. The jump from single-celled life to multicellular organisms might be extremely difficult. For cells to cooperate in a permanent way, they have to coordinate, specialize, and give up some of their individual freedom. Some divide labor, becoming muscle, nerve, or skin. Some reproduce, while others never do. This requires complex signaling, regulation, and a kind of biological trust that defection and cheating won't destroy the group. On Earth, it took billions of years for this transition to occur, and even then, it didn't happen everywhere. Only a few lineages, ancestors of animals, plants, fungi, and a handful of others made the leap. The rest stayed single-celled. If this step is rare, then most life-bearing planets might be forever microbial. Their worlds could be rich with unseen activity, but without forests, animals, or oceans full of large, visible creatures. In that case, we passed another filter when life here became multicellular. Even after multicellularity appears, there is no guarantee of intelligence. Earth's history is a tapestry of countless species that prospered without ever inventing complex tools or culture. Trilobites crawled along the seafloor for millions of years. Ammonites floated through ancient seas. Dinosaurs dominated land ecosystems for an extraordinarily long time. None of them developed radios, telescopes, or writing. Intelligence like ours, abstract reasoning, language, cumulative knowledge, is just one evolutionary strategy among many, and not necessarily the most straightforward. For a very long time, sharp teeth, strong shells, speed, camouflage, and sheer numbers were far more common routes to success. Consider again the dinosaurs. For about 150 million years, they thrived in a wide variety of forms. They lived in forests, deserts, swamps, and plains. They adapted to changing climates, survived countless local extinctions, and diversified into thousands of species. Yet in all that time, none of them seem to have crossed the threshold we associate with technological intelligence. They didn't invent symbolic language as we know it. They didn't develop culture that accumulates knowledge across generations in the way ours does. They didn't build. If intelligence were a guaranteed endpoint of evolution, You might expect it to have appeared long before we did, perhaps in the age of dinosaurs. The fact that it did not suggest that even once you have complex animals, the path to something like human-level intelligence is anything but assured. So perhaps the great filter lies there in the step from complex life to a species capable of building machines, communicating abstract ideas, and transforming a planet. If so, the galaxy might indeed be full of ecosystems, lush jungles, vast reefs, and dizzying arrays of creatures, while only an extremely few worlds ever produce beings who ask questions like these. Even once such beings appear, the road ahead is still precarious. Our own emergence depended on a series of contingent events. About 66 million years ago, an asteroid struck Earth with catastrophic force, contributing to the extinction of the non-avian dinosaurs. That tragedy opened ecological space for mammals to diversify, and eventually for primates to flourish. Without that impact, the evolutionary story might have followed a very different path. Large reptiles might still dominate. The specific branch that became us might never have formed. If the appearance of technological intelligence depends on such accidents, on just the right disasters happening at just the right times, then the odds shrink even further. Many planets with complex life might simply never experience the particular sequence of twists and turns that leads to a species like ours. From there, the chain grows more intricate. Our ancestors evolved larger brains, more flexible behavior, and eventually language. They formed social groups, developed traditions, learned to control fire. They crafted tools out of stone, then metal. They domesticated plants and animals, invented agriculture, and built settlements that grew into cities. They learned to store knowledge in writing, to reason systematically about the world, and to apply that reasoning in science and technology. None of those steps were guaranteed either. Each depended on cultural developments, environmental pressures, and countless strokes of luck. Any number of things could have gone differently. Different climates, different diseases, different conflicts, and the particular thread leading to modern technological civilization might have snapped. When you look back along this path with clear eyes, it's not hard to see why some people find the idea of past filters compelling. There are so many points where life could have stalled, where complexity could have failed to arise, where intelligence could have been snuffed out or never have evolved. The fact that we stand here at all may mean that we have already cleared some of the rarest and most treacherous barriers. In that scenario, the silence of the stars is not telling us that civilizations always destroy themselves. It might simply be telling us that almost none ever get started on the same path we did. If that's true, then we are rare to the point of being almost alone. And while that loneliness is profound, it also means that our future is not necessarily bound to end in the same silence we see elsewhere. Yet we must be cautious. We can't rerun Earth's history to check how likely each step was. We have only one example of life and one example of intelligence. We do not yet know if our journey from molecules to minds is extremely unusual or fairly typical given enough time. This is why the search for life beyond Earth, any life, even the simplest microbes, is so important. If we find even a second origin of life somewhere close by, on Mars, under the ice of Europa, in the seas of Enceladus, it would strongly suggest that life is not an almost impossible fluke. It would mean that the first rung of the ladder is relatively easy to climb. In that case, the great filter, if it exists, must lie on later steps, the development of complexity, intelligence, or long-term survival. That would change how we interpret the silence. It would make our current stage feel more precarious. Until we know more, we live with uncertainty. Yet there is something quietly powerful in recognizing how contingent our existence has been. The fact that you are here, listening, is the endpoint of an unbroken chain stretching back billions of years. Every successful replication, every ancestor who survived long enough to reproduce, every geological twist that kept Earth habitable. If any one link in that chain had failed, we would not be here to ask these questions. That realization can be unsettling, but it can also be grounding. Whether or not we've already passed the great filter, one thing is clear. We carry the weight of an improbable story. Right now, as far as we know, we are the only minds capable of reflecting on this. the only ones who can look up into the night and wonder about filters and fates. That alone makes our survival something more than a local concern. It gives it a kind of cosmic significance. When people first encounter the idea of the Great Filter, many instinctively hope it lies in our past. It's an appealing thought. Maybe the hardest part was getting from chemistry to biology. Maybe the hardest part was arriving at intelligence at all. In that case, the silent sky would be a sign that we're among the few who succeeded, and the road ahead, while difficult, would not be guarded by an invisible, nearly unsurvivable barrier. But there is another, darker possibility, that the Great Filter lies ahead of us, that we have not yet faced the most dangerous tests, and that humanity currently lives in a narrow, fragile window before those tests arrive. This interpretation turns the silence from an abstract puzzle into a potential omen. To think about this, consider where we sit on the timeline. Earth is roughly 4.5 billion years old. Life has existed for most of that time. Complex multicellular life has inhabited the planet for hundreds of millions of years. But humans, modern humans with language and culture, have been around for only a couple 100,000 years. And industrial civilization, the kind that modifies the planet at large scales and produces signals detectable from space, has existed for less than 2 centuries. On the cosmic clock, that is almost no time at all. If there is a great filter ahead, we may be standing very close to it and not yet realize it. Our technologies have given us staggering power, but they have also multiplied our vulnerabilities. Nuclear weapons are one of the clearest examples. For the first time in Earth's history, one species holds the ability to devastate the entire biosphere in a short time. The Cold War brought the world close to disaster more than once. Even now, large arsenals remain. A full-scale nuclear exchange would not just kill millions in an instant. It could darken the skies, collapse agriculture, and trigger a nuclear winter that endangers civilization itself. But nuclear war is only one possible filter. There is also the risk of ecological collapse. Our civilization depends on stable climates, fertile soils, clean water, and functioning ecosystems. We are already pushing those systems hard. Greenhouse gas emissions are altering the climate. Forests are shrinking, species are disappearing. If we overshoot too far, we could cause changes that our social and technological structures cannot adapt to quickly enough. Then, there is the realm of emerging technologies. Artificial intelligence might help us solve problems or create new ones we cannot control. Biotechnology can cure disease or unleash new plagues. Nanotechnology could build at microscopic scales or malfunction in catastrophic ways. With each new capability, we create not just tools, but new forms of risk. Some of those risks may be ones we have never had to navigate before. The idea that the Great Filter lies in our future suggests that most civilizations reach a point like this, a point where their reach exceeds their wisdom. They become capable of transforming and even destroying their own environment faster than their institutions, values, and coordination can keep up. If they fail to manage that mismatch, they collapse. Their brief flicker of technological activity fades before they have any real chance to become visible on a galactic scale. In that case, the quiet of the universe might be less like an unanswered question and more like the aftermath of many failures. This is a grim picture. It implies that the odds are heavily stacked against long-term survival for civilizations like ours. But it also hints at something important. If awareness of the filter is possible, perhaps it can be used. If other civilizations failed because they never fully recognized the dangers they faced, we might have an advantage simply by seeing those dangers clearly. Awareness itself can be a kind of defense. We can choose to reduce weapons rather than pretend they are not a threat. We can confront climate change directly, rather than treat it as a distant inconvenience. We can set careful guidelines around powerful technologies rather than racing forward blindly. None of this guarantees success, but each step increases our chances. Some thinkers suggest that the most important filters may not be purely technological or environmental, but social and psychological. A civilization might have all the tools it needs to survive, but still fail because of corruption, inequality, tribalism, or short-term thinking. It might simply be unable to coordinate at the scale required to navigate global risks. If that is the case, then the core test for a species like ours is not just whether we can invent powerful tools, but whether we can develop the wisdom, cooperation, and restraint to use them safely. If we are before the filter, then our moment in history is incredibly delicate. But it is also incredibly meaningful. Out of all the planets, all the eons, all the possible branches of evolution, we may be one of the few that has reached this stage. The choices we make now could determine whether we join a long tradition of vanished civilizations or become one of the rare exceptions that endures. We don't know which of these stories is true. The filter could lie mostly in the past, in the future, or be scattered in pieces across both. The silence might reflect rarity, danger, or timing, but we cannot avoid the possibility that the most challenging tests still await us, and that our decisions, collectively, will decide whether we pass them. It's hard not to feel a chill at the thought that the great filter may lie ahead like a hidden wall we are marching toward. But there is another possibility that is less often discussed, and in some ways, more flattering. Perhaps the reason we don't hear anyone else is not because we are doomed, but because we are early. Not doomed, not uniquely cursed, just early. In that picture, the universe isn't a graveyard. It's a stage being slowly prepared. The props are in place. Stars, planets, elements, energy. The lights are on. But the actors have barely begun to arrive. We happen to be among the first. At first glance, this might sound unlikely. After all, the universe is about 13.8 billion years old. Our solar system is only about 4.5 billion years old. That means stars and planets had billions of years to form before Earth even existed. If civilizations can arise, why wouldn't some of them have started long ago, billions of years before us? Wouldn't they have had time to spread, build, and make themselves obvious? The silence seems, on the surface, to argue against the idea that we're just early to the party. But timing in the universe is subtle. In its youth, the cosmos was a very different place. The earliest generations of stars were massive, hot, and short-lived. They burned fiercely and died violently, often as supernovae. The heavy elements we need for rocky planets and complex chemistry, carbon, oxygen, silicon, iron, didn't exist in significant amounts at first. They had to be forged inside stars and scattered into space many times over. The universe had to go through cycles of birth and death before there were enough of these elements to build abundant Earth-like planets. In those earlier eras, even if planets formed, many might have lacked the necessary ingredients for life as we know it. Radiation levels were higher, environments were more chaotic. It's possible that for a long time, the universe simply wasn't ready for life, not in any stable, long-term sense. It may be that only after several billion years of star formation and supernova enrichment did galaxies finally settle into conditions that allow life-bearing worlds to be common. If that's true, then the era when planets like Earth can host life might have started relatively recently, in cosmic terms. Our planet's age, about 4 to 5 billion years, could be near the beginning of a long window of habitability across the galaxy. In that case, life appearing here now wouldn't be strange. It would be right on schedule. Even after planets like Earth become possible, evolution takes time. On our world, life appeared quickly, but complex multicellular life took billions of years to emerge. Intelligence capable of technology has existed for only a tiny fraction of the planet's history. If that pattern is typical, then even on worlds where life is abundant, evolution might still be in its early stages. Most life in the galaxy could still be microbial or simple, quietly thriving in oceans and soils, utterly unaware of the stars above. In that scenario, the universe might be full of life, but nearly empty of civilizations. Intelligence like ours might be rare for now, but not forever. Other species may be destined to awaken, to build tools, to look upward. They just haven't gotten there yet. There is also the matter of how long it takes for civilizations to spread. Even if a few others exist right now, they may still be confined to their home systems or nearby stars. Interstellar travel is difficult. It consumes enormous energy and time. We sometimes imagine ancient empires spanning the galaxy, but the reality could be slower and more cautious. Civilizations might expand in fits and starts, or choose to remain mostly local for very long periods. From where we stand, that would still look like silence. Thinking of ourselves as early changes the emotional color of the great filter. Instead of seeing ourselves as latecomers in a galaxy where everyone else failed, we could be pioneers at the beginning of something larger. This view doesn't remove our challenges, but it softens the sense of inevitable doom. If the great filter is mostly in the past or not as insurmountable as we fear, then the quiet sky is simply a sign that the story is just beginning. Being early, however, brings its own responsibilities. If intelligence is only now starting to flower in the galaxy, then how we behave could set a pattern. Our survival or collapse might influence in subtle ways what kinds of futures become possible for others. Our exploration, our ethics, our stewardship of our planet, and our technology could be the first chapter in a much longer cosmic narrative. It's a strange thought. In a universe 13.8 billion years old, we might still be living near the dawn of civilizations. History on Earth is full of moments when timing changed everything. Some species appeared before conditions favored them and went extinct. Others arrived just when the environment opened a niche for them. Some civilizations developed technologies ahead of their time and reshaped the world. Others arose too early or too late to take full advantage of opportunities. If intelligence in the galaxy is only beginning to appear, then from our perspective, it feels like solitude. From the universe's perspective, it might look like the first flicker of a new era. Of course, being early does not explain everything. It raises its own questions. If someone has to be first, why us? Out of all the planets orbiting older stars, why did Earth produce one of the earliest technological civilizations? Is it pure coincidence? Or is there something about our environment, our star, or our galaxy's position that favored our timing? It's possible that randomness alone is sufficient. In any distribution, someone occupies the earliest slot. On a long timeline, someone has to go first. But some researchers have suggested that conditions for life and intelligence might improve over time as radiation levels decline, heavy elements increase, and galaxies stabilize. If so, then there might be a sweet spot in cosmic history for civilizations to arise. We might be near the leading edge of that wave, not impossibly early, but not late either. In that case, the silence of the universe right now would not be permanent. It would be the quiet just before many voices wake up. Whether that is comforting or not depends on how we interpret it. If many civilizations will eventually appear, then we are not alone in principle, but we may be alone in practice for a long time. Being early might mean we have no one to guide us, no older civilization to warn us about pitfalls or help us manage our risks. It might also mean we are the ones who must someday play that role for someone else. If we imagine ourselves as pioneers at the beginning of a long story, then the stakes of our survival grow even heavier. What we do now, how we handle the next centuries and millennia, determines whether the first sparks endure or are snuffed out before the galaxy ever hears them. When we talk about the silence of the universe, people often reach for imaginative explanations. One of the more famous is the zoo hypothesis, the idea that we're being deliberately left alone. It goes something like this. Advanced civilizations know about Earth. They could contact us if they wished, but instead, they watch from a distance and do not interfere, much as we might observe animals in a protected reserve. In that story, the universe is not empty at all. It is full of observers. We are the ones inside the glass. It's a strange, unsettling image. On the one hand, it solves the puzzle neatly. We don't hear anyone because the others have decided not to speak to us. They may have ethical rules against interference, or a shared agreement to let less advanced species develop on their own. This version feels almost gentle, like a cosmic version of the prime directive from Fiction Observe. But do not disturb. On the other hand, the idea can feel uncomfortable. If we are in a kind of zoo, Who built it? Who enforces the rules? What do they think of us? Are we a scientific project, a curiosity, a lesson, a form of entertainment? The thought that someone might be watching while refusing to answer introduces a new kind of unease. The silence is no longer natural. It is intentional. The zoo hypothesis is only one among many attempts to explain the quiet sky without assuming emptiness. Closely related is the notion of quarantine. In that version, we are not just being observed, we are being avoided. Advanced civilizations know we exist, but consider us dangerous, unpredictable, or too primitive to engage with safely. From their point of view, a species that still struggles with war, environmental harm, and internal conflict might not be a good candidate for open contact. If you had the ability to travel between stars, would you rush to meet a civilization just discovering nuclear weapons and global-scale technologies? Or would you wait and watch, hoping they mature before deciding? Another idea is deliberate silence for self-preservation. Picture a dark forest again. In it, every hunter knows that making noise could attract unseen threats. In such a place, the safest strategy is to remain hidden. Applied to the galaxy, the dark forest idea suggests that advanced civilizations may avoid broadcasting powerful signals because they cannot be sure who or what might hear them. They may communicate only in tightly focused, hard-to-detect ways, or not at all. For newcomers like us, listening with broad, primitive ears, the result looks like silence. There are gentler possibilities as well. Civilizations may exist, but their lives might be brief on cosmic scales. They may rise and fall within a few thousand years. If so, the odds of two such civilizations overlapping in time and being close enough to detect each other could be very small. The universe could have hosted many technological cultures in the past, and may host many in the future. But at any given moment, only a few or none are active. We might simply be alone right now. Another consideration is that our search has been narrow and biased by our own assumptions. We listen for radio waves because that's what we know how to produce and detect. We look for certain kinds of megastructures because we imagine them as efficient ways to harvest energy. But there is no guarantee that others would use our methods. Their technologies might be as far beyond ours as ours are beyond Stone Age tools. Their signatures might be subtle or not obviously technological to our current understanding. It's possible that we are like someone standing in a city square, listening only for drums, and ignoring all the quiet, digital signals passing silently through the air. The city might be full of conversation, and we'd never know it. Some have even suggested that we might already be seeing traces of other civilizations, but failing to recognize them. A peculiar star's variability might be dismissed as dust, instead of considered as evidence of engineering. A strange radio signal might be written off as interference. Without a clear, unambiguous pattern, we tend to favor natural explanations, and rightly so, to avoid wishful thinking. But it remains possible that we have been glimpsing hints without realizing what they are. And there is one more idea, that advanced civilizations talk only among themselves. They might create closed networks, galactic internets, that require a certain level of technology or achievement to join. Newcomers like us would not yet have access. From our vantage point, this would look like silence. From theirs, it would look like a rich, ongoing conversation. All of these explanations, in one way or another, suggest that the silence is not telling us that we are alone. It is telling us that we are excluded, unready, or simply listening in the wrong way. That can be oddly comforting. It allows us to imagine that the universe is alive with minds that the quiet is only at our end. But there is a catch. Even if these ideas are true, they do not fully solve the deeper puzzle. Because beyond signals, beyond deliberate silence or hidden conversations, there is still the matter of visible traces. If civilizations spread widely, harness energy on vast scales, or transform their environments dramatically, we might expect at least some of those changes to be detectable, even if no one is trying to communicate. The fact that we have found no unmistakable evidence of this, no clear Dyson spheres, no obviously artificial structures on cosmic scales, means that either such civilizations are exceedingly rare, or their activities are far less conspicuous than we imagine. In the end, the zoo hypothesis and its relatives may say more about us than about the universe. They reveal our desire to populate the silence with hidden company, to turn an empty sky into a stage full of quiet actors. It is difficult, emotionally, to accept that we might truly be alone. So we imagine watchers, guardians, hunters, or distant civilizations that have chosen not to answer. Yet until we find concrete evidence, these remain stories, reflections of our fears and hopes projected onto the night. When we discuss life in the universe, it's easy to fixate on chemistry on oceans, atmospheres, and habitable zones. Those things matter deeply. They are the soil from which everything grows. But the true heart of this question lies with something far more fragile: intelligence. Not just the ability to survive, but the ability to think abstractly, to imagine futures, to build tools that reshape the world, to ask questions about the stars. That spark feels normal to us because we live within it. Yet if we step back and look at Earth's history, we see how rare and precarious it really is. For the vast majority of Earth's existence, there was no intelligence of our kind. Life began around 4 billion years ago, but for nearly all of that time the planet belonged to microbes. They filled oceans and soils, formed mats on rocks, and thrived in environments from boiling vents to frozen ice. They were astonishingly successful. They altered the planet's atmosphere, drove cycles of carbon and nitrogen, and proved that life could adapt to almost anything. But for billions of years, none of those organisms built telescopes. None of them painted, wrote, or wondered about where they came from. Life was everywhere, but minds like ours were nowhere. Even after multicellular life appeared, intelligence was not an obvious destination. The fossil record shows explosion after explosion of diversity, followed by extinctions and changes. Many complex creatures appeared and vanished without ever inventing technology or abstract language. Sharks and crocodiles have survived for ages with bodies and behaviors that changed little. They did not need philosophy to succeed. The dinosaurs are perhaps the most striking example. They dominated for more than 150 million years. They occupied every major environment on land. They evolved into enormous sauropods, agile hunters, and agile flyers. But nowhere in that immense time span do we see evidence of the kind of intelligence that leads to radios and rockets. They had brains and social structures, but not the kind of symbolic, cumulative culture that defines our species. When mammals finally rose to prominence after the asteroid impact, intelligence still didn't arrive all at once. For tens of millions of years, mammals remained mostly small and relatively simple in behavior. Only a small branch primates eventually developed the kind of brains suited for complex social life, tool use, and eventually language. And even among primates, only one lineage, ours, took the particular path that led to cities and spacecraft. Out of the vast tree of life, with its countless branches and leaves, only one twig has carried a species all the way to this point. That is sobering. It suggests that intelligence as we experience it is not the default outcome of evolution. It is an unusual path, dependent on specific events, pressures, and accidents. Evolution doesn't aim for intelligence. It simply favors traits that help organisms survive and reproduce in their local environment. In many environments, large brains are a costly luxury. They consume a great deal of energy. They require long developmental periods and complex social structures to support learning. If a sharp beak, tough shell, or fast legs can do the job, evolution is content. It does not care whether a species can ask philosophical questions. Even once intelligence emerges, it is fragile. Our species did not sweep across the world as an unstoppable force. Early humans lived in small groups, vulnerable to disease, climate changes, and predators. At least once, our population seems to have crashed to very low numbers, perhaps only a few thousand individuals, due to environmental stresses or disasters. In that narrow bottleneck, our entire future balanced on the survival of a tiny fraction of our ancestors. A small shift in circumstances could easily have erased us. Civilization itself is fragile as well. Once humans began building settled societies, they flourished, but they also faltered. Empires rose and fell. Knowledge was gained and sometimes lost. Libraries burned, sciences stagnated, and cultures disappeared. The story of civilization is not a steady climb. It is full of setbacks and breaks. Intelligence, once it blooms, is like a flame in a windy place. It can illuminate and transform, but it can also be blown out. When we view the Fermi Paradox through this lens, the silence takes on a new shade. Perhaps the galaxy does not ring with the voices of civilizations because most attempts at intelligence never last. They arise briefly, shine for a few thousand years, and then fade due to their own internal vulnerabilities. Over billions of years, countless sparks might have lit and gone dark without leaving traces that last long enough for us to see. If that is the case, then the Great Filter is not a single event, but the ongoing fragility of intelligence everywhere. The spark appears but rarely takes hold strongly enough to endure. For us, this possibility is deeply personal. We tend to assume that our intelligence is now a permanent feature of Earth, that, having appeared, it will remain in some form. But it might not. There is no law that says a species capable of spaceflight cannot disappear. Our future is not guaranteed just because we can imagine it. And yet, intelligence brings something new to the table. The ability to look ahead. Microbes cannot reflect on their own extinction. Dinosaurs could not plan for asteroids. But we can imagine both. That imaginative foresight is a kind of power. It allows us to anticipate problems and address them before they destroy us, at least, in principle. This is where the Great Filter returns as a kind of challenge. If intelligence is fragile by nature, then surviving may require using that intelligence to protect itself. Wisdom, in that sense, is not a luxury. It is a survival trait. When people imagine advanced civilizations spreading among the stars, they often picture them as stable, almost eternal, vast, serene, and enduring. But if we look at our own history, we see that complexity can be unstable. Rapid growth, expanding resource use, and increasing power can amplify risks. What if many civilizations burn too brightly, too quickly? They might expand, exploit, and innovate at breakneck speed, only to unbalance their environments or their societies so severely that collapse becomes unavoidable. They might reach a technological peak and then fall apart under the weight of that very success. We can see hints of that dynamic on Earth in miniature. Civilizations that grew too fast, stretched their resources too thin, or failed to adapt to changes often collapsed. They left behind impressive ruins and questions about what went wrong. The difference now is that our civilization is global, and our tools are far more powerful. If the Great Filter lies in the challenge of managing complexity and power, then our task is to learn how not to burn out. We would need to find a way to balance growth with stability, ambition with caution, and innovation with restraint. We would need to build systems that can absorb shocks without tearing apart. That is no small task. But acknowledging how fragile intelligence is, how many things had to go right for it to exist at all, can itself be a source of motivation. If minds like ours are rare, then preserving them becomes not just a local preference, but a kind of cosmic duty. Right now, we don't know whether the universe is full of life or almost empty. We don't know whether other civilizations exist but are hiding or gone. We don't know whether the Great Filter is behind us or ahead. But we do know that at least here, intelligence has appeared, and that it hangs in the balance between our choices and our circumstances. The silence of the universe could mean many things. It could signify overwhelming danger, extreme rarity, or simply that we are early. Whatever the explanation, it highlights how precious our situation is. There may not be many others like it. When you look up at the stars with all of this in mind, the quiet can feel different. It's not just an absence. It's a backdrop that makes our presence stand out. Against that silence, every act of preservation, every step toward wisdom, every attempt to build a more resilient civilization becomes part of a deeper story. We may never know for certain where the Great Filter lies, but we can choose to act as if our survival matters beyond our lifetimes. We can treat intelligence our own and the potential for others as something to protect, nurture, and pass on. The universe may be indifferent, but we don't have to be. And here gently, is where that thought settles. If the cosmos is quiet, because minds like ours rarely emerge or rarely endure, then our task becomes clear. Hold on. Take care. Learn. Because it might be that, for now, we are the only ones able to do so. The strangest feature of the universe is not the explosive brilliance of supernova, the graceful swirl of galaxies, or even the mystery of black holes. It's the quiet, the vast, almost unbroken quiet that stretches across unimaginable distances with no clear sign that anyone else has ever spoken. By all our reckonings, the universe ought to be noisy. Our calculations tell us it should be humming with activity, rich with the signatures of advanced life. Signals, structures, patterns that announce we were here. Yet no matter how we look, no matter how we listen, we keep encountering the same response. Silence. This silence isn't mere absence. It has a shape to it, a consistency. Every time a telescope surveys a new region of space and finds only natural phenomena, starlight, gas, dust, radiation, the silence deepens. Every time a radio dish listens for structured transmissions and hears only static and known sources, the quiet becomes more pronounced. This isn't the result of a single failed experiment. It's an accumulation. A long series of no answers to a question we keep asking in different ways. At some point, we must consider that the lack of response is itself meaningful. Perhaps we are not asking the wrong question. Perhaps the answer really is that no one is answering. What makes this so striking is how starkly it clashes with the scale of the numbers involved. Hundreds of billions of stars in our galaxy alone. Trillions of galaxies in the observable universe. Planets around most stars. Common chemical ingredients for life. Time intervals spanning billions of years in which civilizations could have risen, spread, and transformed entire regions of space. Against that abundance, the quiet feels almost unnatural. It's as if you walked into a rainforest expecting a riot of soundbirds calling, insects buzzing, leaves rustling, and instead found it as silent as a painting. When humanity first pointed radio telescopes toward the sky with the intention of listening, there was hope. Sometimes even expectation that we might quickly pick up something artificial. A simple tone, a repeating pattern, a signal encoded with mathematics or images. As years became decades, the initial excitement softened into a more measured patience. We've surveyed more stars, broadened the range of frequencies we listen to, and built more sensitive instruments. Still, no unambiguous message has arrived. Some caution that our search has barely begun. The volume of the galaxy is enormous compared to the narrow slices of sky and frequency we've probed. We've skimmed a few pages from an unimaginably long book. From that standpoint, it's true that the lack of results so far does not definitively prove anything. Yet the pattern remains. For all our efforts, every promising anomaly to date has either failed to repeat, faded into noise, or found a likely natural explanation upon closer inspection. The universe continues to behave as if we are alone, even if we resist that conclusion. This ongoing silence is the core data behind the Fermi Paradox. We can debate probabilities and mechanisms. We can adjust the parameters of the Drake equation. But the stubborn fact remains. We see no clear evidence of other civilizations. That is not a blank. It's a signal of its own, a quiet but persistent statement that something about our assumptions is off. Psychologically, this weighs on us. Human beings are social by nature. We expect company. We fill our world with voices, stories, and connections. Even when alone, we imagine others. We conjure deities, spirits, and distant minds. The idea that, on the grandest scale, no one else might be there is hard to absorb. It's not just lonely. It can feel like a challenge to our sense of meaning. Faced with that, we often respond by populating the silence with our own inventions. We picture watchful observers, hidden networks, or secret rules that keep everyone quiet. These stories comfort us by suggesting that we are not alone, only isolated or uninvited. The silence becomes intentional rather than empty. Yet until we find evidence, those stories remain just that. Our reflections projected onto the stars. Another troubling aspect of the silence is its duration. The galaxy is old enough that even a slowly expanding civilization, using relatively modest technology, could in principle spread across it in tens or hundreds of millions of years, a blink in cosmic time. If even one such civilization had appeared 1 billion years ago and survived, its influence might now be visible almost everywhere. Instead, we see no clear signs that anyone has ever reshaped the Milky Way on that scale. Everything we observe, star distributions, radiation backgrounds, planetary motions, looks natural. Not untouched exactly, but not obviously engineered. The sky does not show us a galaxy remade by intelligence. It shows us a galaxy following the rules of physics and chemistry. Some find reassurance in this. If no advanced predators or empires roam the stars, perhaps the universe is safer than some dark visions suggest. But comfort quickly gives way to a new unease. If there are no empires because none ever appeared or endured, what does that imply for us? If it is so hard to last that no one has managed it on galactic scales, why should we expect to be the first? It is also possible that the silence is not a final verdict but a temporary condition born of our current limitations. Our tools are improving. Our understanding of the cosmos deepens each decade. There may be signals, traces, or signatures of life that we simply don't yet know how to detect or interpret. The quiet might someday prove to be an illusion born of ignorance. But we cannot build our worldview on possibilities alone. We must take seriously the one clear thing we do see. A universe that, as far as our instruments and knowledge can tell, does not openly reveal other minds. That realization has consequences. If we are alone or nearly alone, then our survival matters more than we might previously have imagined. If we are not alone, but others have fallen, then our survival still matters, because we may be among the few left to carry consciousness forward. Either way, the silence elevates our responsibilities. It forces us to see ourselves not only as inhabitants of one planet, but as potential guardians of something rare in the cosmos: self-aware life. This brings us to the most intimate point of all, the fragility of our future. It is easy, standing inside a functioning civilization, to assume that it will continue indefinitely. Cities feel solid, technologies feel reliable, institutions once established feel enduring. But history and physics tell a different story. Everything we build is temporary. Everything we depend on is contingent. Our planet's habitability depends on a thin layer of atmosphere, a particular balance of greenhouse gases, a certain range of temperatures, complex ocean and climate dynamics. Our civilization depends on stable food supplies, functioning infrastructures, shared agreements, and social cohesion. All of these can be upset. We have global risks unique to our technological age: nuclear arsenals, climate disruption, engineered pathogens, unaligned artificial intelligence, and others we may not yet perceive clearly. Any one of these could serve as a kind of filter if mishandled. Together, they form a landscape of potential pitfalls that we must navigate with care. Recognizing this fragility is not a reason to succumb to despair. It is a reason to take responsibility. A glass is fragile, but with care, it can endure. A flame is fragile, but it can be sheltered and fed. Our civilization is fragile, but it can be strengthened. That strengthening begins with clear-eyed awareness. We must acknowledge the existence of these risks, rather than deny them. We must work to reduce them, even when doing so is difficult or uncomfortable. We must steer our technologies and our systems with foresight, not just short-term gain. It also requires cooperation. The challenges that threaten us are global. No single group can manage them alone. Fragmentation, hostility, and zero-sum thinking make survival less likely. Collaboration, dialogue, and shared goals improve our odds. In a universe that appears silent, dividing ourselves into narrower and narrower factions is a luxury we can ill afford. There is, finally, a quieter dimension to all of this: gratitude. If intelligence is rare, if civilizations are fragile, then our existence is not just precarious, it is precious. Every day that we continue, every problem we solve, every work of art, every act of kindness, every piece of knowledge preserved, contributes to something that may not happen often in the universe. The silence of the cosmos, in this light, is not merely ominous. It is also a backdrop that makes our presence stand out in relief. Against that vast, unspoken dark, even a single small voice can matter. The great filter, whatever and wherever it is, confronts us with a stark possibility that most who reach our stage do not make it further. But it also leaves open another possibility, that some do. That survival, while difficult, is not impossible. That we might be among those who find a way through. Hope, in this context, is not blind optimism. It is the recognition that we exist at all. That against immense odds, life arose, complexity blossomed, intelligence emerged, and a civilization capable of reflecting on its own fragility formed. That chain of events may have been extraordinarily unlikely, yet here we are. The very act of worrying about our fate, of discussing filters and futures, is itself a sign of potential. Dinosaurs did not contemplate their extinction. Collapsed civilizations of the past did not possess our level of scientific understanding. We do. That awareness is not a guarantee of success, but it is a tool we can use. Fear of failure can paralyze, but it can also focus. When we fear nuclear war, we negotiate treaties and reduce arsenals. When we fear environmental collapse, we seek cleaner technologies and new ways of living. When we fear unbounded AI or dangerous biotechnology, we begin conversations about ethics, safeguards, and regulation. Our fears, when faced honestly, can become guides. In the end, the great filter is not just a speculation about distant stars. It is a way of framing the question of what kind of species we wish to be. Will we be one more fleeting flare in the dark brilliant for a moment and gone? Or will we become something that endures, that travels, that shares what it has learned, that perhaps one day hears another voice and replies? The silence of the universe offers no guarantees. It provides no comforting script. It gives us only a blank page on which to write. That blankness can feel like a weight, but it is also an invitation. And so we return, gently, to where we began, to you, listening somewhere under this same sky. Maybe you're lying in bed, lights low, eyes growing heavy. Maybe you're walking alone through quiet streets, glancing up between buildings at a few scattered stars. Maybe you're sitting at a desk in a small island of calm carved out from a busy day. Wherever you are part of this story, part of the only known civilization capable of having these thoughts. Part of the fragile thread that may or may not stretch into the far future. If this reflection has brought you some measure of calm or curiosity, or simply a sense of companionship in the face of such vast questions, I'm glad you were here. If you choose to leave a like or subscribe, it helps this small, quiet corner reach others who might need a gentle place to think about things that are too big to face alone. But more important than any of that is the thought I hope you carry away, that we are fragile, and we may be rare, and that makes us precious. That survival is not assured, but it is possible, and possibility is enough to make effort worthwhile. So let this not be a final farewell, but a soft pause, a kind of quiet wave across the stars, offered from one small world into a universe that is not yet answered. The story is not over. It may be that on the grand scale of cosmic time, it has only just begun. Our task now is to decide how we will write our chapter. Will we let the silence remain unbroken? Or will we, carefully, patiently, teach the universe to speak? For now, we rest here, between questions and answers, between fear and hope, between fragility and resilience, listening to the quiet and choosing, in our own small ways, to keep going.